Hi, I'm Atul and I'm an online tutor based in London right now.
Hi, I'm Paul and I'm a chemistry tutor based in Burnley, Lancashire right now.
In this video, we'll be looking at why chlorine has a relative atomic mass of 35.5. In an earlier video, we looked at isotopes. So this one just goes using to isotopes explaining why we get this 35.5 when you look at the periodic table as a mass. So chlorine has two isotopes, as we mentioned earlier, chlorine 35 and chlorine 37. So once again, we'll build the nuclear structure of both isotopes and then go on to explaining how to work out this 35.5. Okay, so just like before, here is chlorine 35, and what we've got here is an empty nucleus which we can fill in gradually with the protons and neutrons, the appropriate number. So here is one proton, one neutron, and this process is continued all the way until we get it's got 17 protons, 17 neutrons at this point, and then one extra neutron here. So 17 protons and 18 neutrons, giving you a mass number of 35. And the other isotope of chlorine is chlorine 37, which is here. The only difference between chlorine 37 and chlorine 35 is that chlorine 37 has two extra neutrons, which we placed on here. So to again show the difference between the two, that's chlorine 35, that's chlorine 37 with the two extra neutrons. And onwards to the calculation that gives us 35.5. So I'll move that over to you, Paul.
Okay, that's great. And we can mention here the definition of an isotope, that it's just got a different number of neutrons in the nucleus. So it's got the same amount of protons in the nucleus, but a different number of neutrons. And we could clearly see that with the chlorine 35 and the chlorine 37 isotope. The 37 had two extra neutrons in the nucleus. And we know from experiments that there's more 35 chlorine isotopes than there are chlorine 37 isotopes. And we've got an inkling of that from the relative atomic mass being 35.5. So we know if it was 50-50, then our relative atomic mass would come out at 36. If there was equal amounts of chlorine 35, 37, we'd have a relative atomic mass of 36, but we don't. We have a relative atomic mass of 35.5. So there must be more chlorine 35 than chlorine 37. And from experiments, we do know that there's actually 3 times as much chlorine 35 than there is chlorine 37. So perhaps, Atul, you could show us that how a representation of that we've got 3 times as much chlorine 35 as chlorine 37.
Great. So from maths, that's basically 3 35s and 1 37, actually, so a ratio 3 to 1. Okay, so I'll make a copy here of the same thing. So here's our 3 35s, and then we know that there's 1 37 as well, and that's our 37. And again, the only difference between the 35 and 37 is that you've got the 2 extra neutrons in 37.
Excellent. So that shows us all the particles in the nucleus. And to work out an average, which is what a relative atomic mass is, it's the average mass of all the nuclei that exist, all of the isotopes of elements. Rather than adding up each individual blue and red dot there, which could take us quite a while, we know that 3 of them have 35 particles and the last one has 37. So we could simply add up 35, add 35, add 35, so that's our 3 chlorine 35 nuclei, and a 37, and then simply add all that up, and what would we get if we added all those particles up?
I am going to get my calculator out for that one, rather than do it mentally. That takes us to 142.
Excellent. So we know altogether here on this page, if we were to add all these particles up, we would get 142 protons and neutrons. And then to get the average, we know we've got 4 nucleuses here, so we would just divide that by 4.
Very reassuringly, my calculator tells me 35.5.
Excellent. And we know when we started this video, we saw that the relative atomic mass of chlorine was 35.5. And that's the reason why, because there's 3 times as much chlorine 35 isotopes as there are chlorine 37 isotopes.
Fantastic. So it's some sort of a weighted average, isn't it, really, taking into account how many of those are there. So if you had, for argument's sake, if you had a lot of 35s, nearly like 90% or 95%, the average would be skewed more towards chlorine 35. And that's something we'll look at in another video as well, where we do these calculations with much more skewed distributions. Fantastic. Well, that's a good one. It's just good to see it all happen visually and quite literally. Look forward to the next one where we go into more depth.
Okay, thanks, Hassel.
Thanks, Paul. See you.